Hello everyone, I hope you are doing well. In this video, we are going to find out the indices of planes for planes in a hexagonal crystal system. Okay, here we'll be given with some of the planes, and these planes will be lying inside a unit cell of hexagonal crystal system. Okay, and we have to use appropriate methods to find out the indices for those planes. Okay, now when it comes to HCP, when it comes to hexagonal system, then we have to find out 4 indices in place of 3 indices to completely describe its direction in planes. So here we'll be finding out 4 indices, which we also call as Miller-Bravais indices. The 4 index system is also known as Miller-Bravais indices. And so here we'll be finding out 4 indices, or we can say we are finding Miller-Bravais indices for planes in HCP. Okay, while conversion from 4 index system to 3 index system is also possible by some transformation equations. The similar problems on this transformation has already been uploaded. You can check it out in solid state physics English playlist. Okay, if you only understand English, and if you understand Urdu and Hindi also, then you can visit other playlist on solid state physics for many other stuff. Okay, so yes, in this video we'll be finding out Miller-Bravais indices for planes in HCP, or we can say the indices of planes for planes in a hexagonal system. And first of all, we'll see some general step that we take in order to find out the indices. Okay, after that we'll have a look at the coordinate system, the 4-dimensional coordinate system that is defined for HCP. Because if we are going to find out 4 indices, then there will be 4 coordinates, or in other words, there will be 4-dimensional coordinate system. So first of all, we'll understand that coordinate system, and after that we'll do many problems. Okay, that will be very different from each other, and if you follow me throughout the video, you will understand the method, and whatever kind of problem comes to you, you will be able to solve it. All right, so stay tuned. Now let's see the general steps, and after that we'll have a look at the coordinate system. And it's advisable that you don't miss, you may not miss any of the thing. Okay, so here the first step is to define the coordinate system in HCP. System in HCP. Okay, first of all, you have to figure out what your coordinate system is. All right, you have to define its origin and its 4 axis named as system with 4 axis lines named as in Cartesian coordinate system. We know that we named the 3 coordinates as x, y, and z. Okay, now here what we call those 4 axes as a1 axis, a2 axis. These are in subscript of a. Okay, a3 axis. These three axis lines will be lying on the basal region of the HCP structure. We'll see it. Okay, and the height axis, which is z axis. Okay, these 3 will lie on the base, while this is the height axis. A1, A2, A3, and Z, these are the 4 axis lines in HCP. And first of all, we have to define the coordinate system. All right, because the basic step is to see whether the predefined coordinate system that we are given with, because if you are to find out the Miller indices of a plane, then in question, for example, in question paper, you will be given a plane in HCP, and there will be a predefined coordinate system. If it is any, then you have to check that whether the plane is passing through the origin of the HCP or not. If it is passing through the origin, then you have to shift the origin, or you have to change the coordinate system. Okay, that is why we are mentioning it properly, that define the coordinate system and make sure that your coordinate that the origin of your coordinate system doesn't intersect the plane whose Miller indices you are going to find out. Okay, you have to make sure. So this is the first step that you have to do. Second step is to find out the intercept. Intercept of plane with each of the 4 axis lines. All right, we'll see it when we'll apply it. Okay, I'm just writing here the general step that we'll be following. Everything, every word that I'm using here will be clear to you that what that word means. Okay, intercept is the point where the plane touches the axis lines. Okay, this is the general definition. You'll see it. I'll explain it further. So after finding out the intercepts, once you know the intercept to A1 axis, intercept to A2 axis, intercept to A3 axis, intercept to Z axis, when 4 of the intercepts are known, you have to take inverse of each of the intercept. Okay, you'll take the inverse of each of the intercept one by one. All right, and after taking the inverse, remove fractions if any. If there is any fraction involved, then remove it by multiplying it with a suitable digit. Okay, multiplying all of the indices with a suitable digit. If you are performing a operation on one index, then you have to do it on all of the index. Okay, in order to neutralize the effect. And in removing the fraction, you cannot multiply it with the negative number. The multiplication or division or any kind of operation you are performing on these digits, they should be positive. Okay, negative numbers should not be multiplied or divided or something like that. Okay, remove fraction if any, and you will get Miller indices of the plane. Indices, enclose them. Okay, enclose them in circular or round brackets in following order: H, K, I, and L. Okay, H will be the index corresponding to A1 axis, K is the index corresponding to A2 axis, I is the index corresponding to A3 axis, and L is the index corresponding to the Z axis. Okay, the number that you will get after these steps corresponding to A1 intercept will give you H. Okay, corresponding to A2 will give you K, corresponding to A3 will give you I, and corresponding to Z will give you L. Okay, now if you want to know what is the most important step, the most determining step that will determine the indices of the plane is to finding out the intercept. If you have found the intercept, then you are good to go. The main and tricky part is to find out the intercept of the plane which each of the axis line. Okay, this is the most crucial part, and the rest of the steps are very easy. They are very easy. There is nothing tricky in them, but finding out the intercept is the tricky one thing. So let us now see what the HCP structure look like. Okay, and how the coordinate system is defined in HCP. So let's jump into that part of the video. Besides these steps, there are the two mathematical equations that will help us a lot in determining the indices of planes, and these two equations are, first equation is true. It is true for HCP only. Okay, this one equation specifically, H plus K plus I equals 0. Okay, some of the first 3 Miller-Bravais indices corresponding to the basal plane is 0. Okay, this is the index corresponding to A1 axis, index corresponding to A2 axis, index corresponding to A3 axis. Okay, there's some will be equals to 0. So if you know 2 of them, you can find out the third one. Okay, for example, if you know the Miller indices for H and K, then by just plugging the value of H and K right here, you can get the value of I. For example, keeping I here and taking these two onto the other side of equation, this is what you will get, and using this formula you can get the value of I if you know H and K, and also for K, and so on. Okay, so this is the equation. This is the mathematical statement that is true for HCP, and you can use it. And the second is the equation of plane, which is true for any plane. Okay, whether it is in cube or in HCP. Okay, you can use it for a plane in cubic lattice, in any other lattice you are considering. Okay, so it is true in HCP also, when it is like equation of plane, and a1 by a plus a2 by b plus z by c equals to 1. Okay, where a1, a2 and z are any point on the plane. Okay, it will be more clear to you when we'll use it. Okay, and a, b and c are the intercepts. Alright, so we can determine intercepts of a plane by using this equation very easily. If you understand the application of this formula, then it will become very easy for you to determine the intercepts for a plane, and if you know the intercepts, you can easily determine its indices. Alright, so yeah. The application of this formula is slightly different from the one that we use in Cartesian coordinates, where there are only three coordinates actually, x, y and z. But in HCP we know that there is a third coordinate a3 also, and while finding out the coordinates of a point that we have chosen on the plane, we have to neglect completely the a3 axis, and we have to assume that if there is no a3 axis. Okay, so the coordinates of a points have to be determined by just moving along a1, a2 and z axis. So the application of this formula needs to be learned, and it will be learned through practice. So stay tuned in this video, where actually the second plane would require us to use this formula, and all of the planes that we come after the second example will require this formula to be used. And even you can use this formula for the first plane that I'm going to use, but I'm making you understand different techniques that you have to use, that you can use to find out the intercept. So the first one is the very simple one, while the other ones that are coming on the way are complex ones. So stay tuned and learn the application of this formula. So get ready with pencils of different colors, because they will help you to distinguish between different planes in HCP. Okay, it's always advisable to use pencils of different colors when you are drawing crystals. Okay, it helps you a lot in understanding the structure. Okay, first of all, I'm drawing here the basal, the roof region. Okay, diagonal line like that. Okay, and similarly here on three narrow lines. Okay, it is starting from this 1 block, 2 block and 3 block. Similarly here. Okay, join these points together. Alright, now we'll draw some vertical lines from each of the point, and these vertical line will comprise 4 blocks. Okay, 4 or 5 blocks, let's say 3, 4, 5. Okay, each line will be comprising of 5 blocks. So 5 block, 1, 2, 3, 4 and 5 block, 1, 2, 3, 4 and 5 block, 3, 4 and 5 block, 5 blocks. Okay, all the 5 blocks are done. Now I am going to join these blocks together just like they are joined. So these two vertical lines will be joined in the same fashion as they were joined upward. Okay, so like that. Horizontal line below there, if there is horizontal line there, then it will be horizontal line there also. Diagonal line here, so diagonal line here also. Similarly, yes, and here it is. Okay, this is the HCP unit cell that I have drawn, and it's so pretty. The prettiest HCP structure that I have drawn so far. And now the centermost point, this is the basal region. Okay, the base region is known as the basal region, specifically in HCP. Okay, this is the basal region. Okay, the centermost point is the origin. Okay, this centermost point is the origin. And all right, so now from center, okay, to this corner, this line, this axis line is A1 axis. Okay, this is A1 axis. All right, now leaving this corner, the next corner, okay, this corner, leaving this corner, the next corner will correspond to the second axis line, which is A2. Okay, This is the A2 axis. Now leaving this corner unchanged, this one corner from center to this one corner will give you the third axis line, which is A3. Okay, and you can see here the three of the coordinate axes are lying on the base region. Okay, they are lying flat on the base region, while the fourth axis will be vertically upward like that from center, and this is the Z axis. Alright, and this is the 4D coordinate system in HCP. And following this coordinate system, we have to find out the intercepts and the Miller indices, Miller-Bravais indices of HCP planes. Alright, I hope it is clear to you now. The intercept to A1 axis, the intercept to A1 axis will give you H. Okay, after performing the steps that are has to be done as I told in the general step. This A2 axis intercept will give you K index, A3 intercept will give you I index, and the Z intercept will give you the L index. Okay, so this is how it will work. Now if this is the positive A1 axis, then a line just opposite to that will, let me make it clear, this is positive A1 axis, so a line just passing through the opposite corner, this one line just opposite to A1 axis is negative A1 axis. Okay, just like we have positive x-axis and negative x-axis, we have negative A1, A2, A3 and Z axis also here. Okay, this is positive A1 axis, this is negative A1 axis, this is positive A2 axis, this is negative A2 axis, this is positive A3 axis, and this is the negative A3 axis. Alright, and this is obviously the origin, and negative Z axis doesn't need to be mentioned here. Okay, yeah, now HCP structure is clear. Now we'll move to the problems and their solutions. So here is the plane whose Miller-Bravais indices are indices we are going to find out, and there will be other planes too. Okay, and we'll do them one by one. Here's the first one. I'll draw this plane right into the paper. We have already drawn a HCP unit cell, so that I can refer to you people and make you people understand how the intercepts are gonna be determined. Okay, so let me draw it on the paper. You can see it clearly where the plane is lying. For initial thought, you can see here that the plane is intersecting the A3 axis right into this point. Okay, this is the plane. Here's the plane, and you can see the axis lines to be this, this and this. Okay, these are the basal lines. We'll talk about the z-axis later. Okay, I refer to this figure also on the paper. Okay, but for the initial thoughts, I'm just to make you people understand the diagram itself, that the plane is intersecting the A3 axis right at this point. Okay, right at this point, so it is intersecting A3 right at the corner of the unit cell. So now you can people see that the plane is intersecting A3 right at the corner of the unit cell. If the plane is intersecting at the corner of the unit cell, then that numerical value will be taken as 1. Okay, so the intercept will be taken as 1. All right, if it is intersecting right at the middle, for example here, then we will take the intercept to be 1 by 2. Okay, if it is intersecting at 1/3 point, then we will take it as 1/3 and so on. Okay, depending upon which fraction of the full length the plane is intersecting, we take its numerical value depending upon that. Okay, if it is intersecting right at the corner, okay, then we'll take it as 1. If it is intersecting at the middle of the full length, okay, then we'll take it as 1 by 2 and so on. I'll make it clear also on the paper for you people. And now we know that the intercept of A3 is 1. Now if you talk about the A2 intercept, then here is the A2 axis. Okay, is going like that, and if you notice, then the corner just opposite to A2 corner is this one corner. Okay, so it is negative A2 axis. It corresponds to a negative A2 axis. This is the positive A2 axis, and that would be the negative A2 axis. And the plane is intersecting the A2 axis at the negative direction and also at the corner of the unit cell. So the intercept corresponding to A2 will be taken as -1. All right, and if you consider the A1 axis, which is in this direction, and also you can see the plane's base, which is this baseline, is also in this direction, which is parallel to A1 axis. So the plane is actually parallel to A1 axis, because the base of the plane is actually the plane's part. Okay, so if it is parallel to A1 axis, then the plane as a whole will be parallel to A1 axis, and two parallel lines never intersect each other. They intersect at infinity mathematically. So the A1 intercept would be taken as infinity. And the similar is true for z-axis. As you can see here, these vertical lines. Okay, here that the plane's vertical line, these are the plane's vertical line. Okay, and they are parallel to the z-axis, as the z-axis is vertically upward, and the plane also has the boundary lines. Okay, you don't need to see all of the lines, you can see the boundary lines, and the boundary lines are these ones. Okay, and they are parallel to the z-axis. So corresponding to z-axis, the intercept is infinity also, because the plane is parallel to the z-axis, and hence they will never intersect. And mathematically we can write this as the intercept to be infinity. So A1 and Z intercepts are infinity, while A3 and A2 intercepts were discussed to be 1 and -1 respectively. Now let us see this image also on the paper. I hope you got it. So if I shade that one plane which we discussed right now, this is the plane. Okay, and clearly it is intersecting, this is the A3 axis. Okay, and here is the plane, and this is intersecting the A3 axis. It is touching the A3 axis at this point clearly, which is the end of the, which is the corner of the unit cell. And we take the whole length from origin to the corner of the unit cell. Okay, along the axis direction, the length will be taken as 1. Okay, along the axis direction, not any other, it will be taken as 1. All right, and if it is touching at half of the point, okay, half the distance from the corner of the unit cell, then it will be taken as half, and so on. Okay, depending upon the fractional distance from the corner of the unit cell, and hence the intercept corresponding to A3 axis will be 1. And here is the positive A2 axis, and here is a negative A2 axis, and the plane is intersecting this axis, A2 axis, at this point in the negative direction. So its intercept will be taken as -1, since it lies at the corner of the unit cell. And we can also see the boundary lines here. This is the boundary line, and it is parallel to A1 axis. Okay, it is clearly parallel to A1 axis, that is why its intercept will be taken as infinity. And similarly for z axis, the intercept will be taken as infinity, because the boundary line of the plane are parallel to z axis. Okay, hence we have A1 intercept, okay, A2 intercept, A3 intercept, and Z intercept to be A1 intercept is infinity. Okay, A2 intercept is -1, A3 intercept is 1, and Z intercept is infinity again. Now we'll take the reciprocal. Okay, the second step is to take the reciprocal, and taking the reciprocal of infinity, 1 over infinity, which comes out to be 0. Okay, 1 over infinity is equals to 0. We'll take inverse of -1, and it is -1 again. Inverse of 1 is again 1. Inverse of infinity is 0. So we got 0, -1, 1, and 0 as the final indices, because We can see here there is no fraction involved. That is why these are the final Bravais indices or indices of plane for this specific plane. Hence, I will enclose these digits in a round bracket. The first index was 0, second as 1, third as -1, that we represent as 1 with a bar on it. Okay, 1 with a bar on it, or any numerical digit with a bar on it means it's a negative number. Okay, so -1 and 0 again. So these are the Miller indices, Miller-Bravais indices for the plane, for this plane. Okay, now let's do the next problem. This problem was pretty easy because all of the intercepts were easily determined by just looking at the figure, but there are some problems, other problems where we cannot have an idea of intercept by just looking at the figure. We have to use the mathematical tools, and the mathematical tool that I'm gonna show you is very easy, and you can determine the Miller indices very easily via those mathematical tools. So here's the next plane, and we can see here the plane in the orange shade. Okay, and if we see here, if we keenly see the boundary lines of the plane, then here are the boundary lines of the plane, and the coordinate axis are also predefined here. Okay, and we can see here. All right, now these are the axis line, and the plane, the green line you can see here, is intersecting the three axes at some point. Okay, at the basal region, and for the z intercept we'll do it later, but first of all let us see where the plane is intersecting the a1, a2 and a3 axis. For that, let me remove these colors. Okay, now you can see here for the case of a1 axis, okay, that it is a 3D diagram. Don't confuse that this plane is intersecting a1 axis at this point. No, it is not intersecting here. The plane is not there. If you imagine its position, then it will be very clear to you that the a1 axis is just beyond this plane. Okay, this plane is away from a1, positive a1 axis. It is not intersecting it at positive a1 axis, but this is one of the corner a1 axis, and the corner just opposite to that a1 axis is this one corner. Okay, this this one corner, and it is negative a1 axis, and the plane is intersecting it right there. Okay, at a negative a1 axis. So the intercept for a1 will be corresponding to the a1 axis will be -1. Okay, for the reason that here is the corner, and the corner just opposite to it will correspond to the negative a1 axis, and the plane is clearly cutting it at the edge of the unit cell along the negative a1 direction. That is why the intercept along a1 direction will be taken as -1. Okay, now let's talk about a2. Here is the corner for a2, and the corner just opposite to the positive a2 direction is this one. Okay, and the plane is clearly touching it at this point. All right, so similarly this was the positive a2 direction, hence this is the negative a2 direction, and hence the intercept for a2 axis will be taken as -1 also. Okay, you can see here that the plane is cutting a2 axis at the negative direction and at the corner of the unit cell. That is why its intercept will be taken as -1. All right, now if we talk about the intercept corresponding to a3 axis, we can have an idea, a rough idea. We can see here that it is cutting, here is the plane. Okay, and and this is the axis line, and we can see here it is cutting, the plane is cutting the a3 axis somewhere at the middle. Okay, somewhere at the middle of this whole length. This whole length is 1, and half of it is 1/2, so it is cutting at at half. Okay, the plane is cutting a3 axis as half in positive direction. We can also confirm it whether it is half or not, because we have that equation h plus k plus I equals 1. Okay, h plus k plus I equals 1, and remember that this equation holds for the Miller indices, not for intercept. So first of all, if you want to know the value of I, which is the intercept corresponding to A3 axis, okay, so what you have to do is to first find out H and K, taking the inverse of A1 and A2 intercept, okay, will give you the H and K values. So you can find out the value of I from that one. Also we can confirm it from these two equations whether the intercept corresponding to A3 will be 1 by 2 or not. Okay, we can confirm it. We can even don't need to find out intercept that way. We will finally find out the value of index corresponding to A3, that will be I. And for Z, I'll give you some other method that will help us to determine the Z intercept very easily. So we have successfully found the intercept, A1 intercept to be -1, A2 intercept to be -1 again, okay, and the A3 intercept is half, but if you want to confirm it, you can do that. For this, you need to find out the value of H, and H will be equals to the inverse of -1, because we take inverse of intercept. Okay, in that case, inverse of -1 is again -1, and there is no fraction involved. That is why -1 is the final index. And similarly, because there is no fraction involved when we take the inverse of both of these quantities, that is why taking the inverse will give us the final Miller indices for H and K. Now we want to find out the value of I, and for that purpose we'll use this equation, okay, where I will be equals to -H minus K, and I equals to minus, taking minus common, H plus K, okay, minus into H is -1, K is -1 again, so minus into -2, that will give us 2. So the index is I is equals to 2. So if you want to find out the corresponding intercept, we take the inverse of index, that will give us intercept. Okay, if you take the inverse of this A3 intercept, which is 1 over 2, you will get I, and for this you will do that and it will result into 2. So it's confirmed that I, which is the third index, comes out to be 2. So we now know 3 of the index, -1, and 2, but the fourth index needs to be determined, and for this we'll use the equation of intercept. We know that equation of plane, okay, A1 by A plus A2 by B plus Z by C equals 1, okay, where A and B are the intercepts corresponding to A1 and A2 axis, okay, and C is the intercept for the Z axis, okay, which is something that we need to find out. C is something that we need to find out because C is the Z intercept, okay. A and B are known, okay, A and B are -1 and -1, and A1, A2 and Z are any point on the plane, any suitable point on the plane, okay, an appropriate point has to be taken so that we can find the value of C. And in taking the point on the plane, do remember that whichever intercept you want to find out, for example here we want to find out the Z intercept, so the Z point, now the Z coordinate shouldn't be 0, okay, of the point on the plane that you are selecting to put into this equation, because if the Z is 0, then this whole quantity will become 0 and C will be eradicated from the equation, and but C was something that we wanted to find out, okay. So I hope you got the point that the appropriate point is the one whose that coordinate is not 0, whose intercept we want to find out. All right, and depending upon the unknowns also, you'll see its application in later problems, okay. So let me take one point on the plane and I will get you people onto that page where the plane was. Now let us take a point on this plane, okay, and that point should have the Z coordinate to be non-zero, okay. We should keep that thing in our mind. So now let's see what we can do here. The most suitable point to me looks like this one, okay. This is the most suitable point, or this one, that one, but the first one is better. Now we need to find out the coordinates of this point, okay. Starting from origin, what we have to do, what a movement are needed along the axis lines to reach that point. Those movements will define the coordinates. So starting from origin, here we have to move 1 unit along the positive a1 axis, okay, at that corner. The line was not straight, but along the axis line of a1 to that corner of the unit cell, so that we have to move 1 unit along a1 direction, okay, positive a1 direction, and from that point onwards we have to move 1 unit along the z-axis. 1 unit means to the other corner of the unit cell along the z direction, which is this point. Okay, so we reached that point now, and that point is what we needed, and that point is the one that we are going to put into the equation of plane equation. Okay, so here we have to move 1 unit along the z direction, and no motion along a2 axis is needed to reach that point. So no motion is needed across the a2 axis. Okay, a3 axis is neglected here, keep that in mind. We are considering only a1, a2 and z axis here, and also in accordance to the equations requirement, a3 axis is not considered. So no motion is required along the a2 direction, and hence for a1 the coordinate is 1, for a2 the coordinate is 0, and for z the coordinate is 1. And the a1 a2 intercepts are known also. Okay, we'll just plug their values into that equation. Keep that in mind, these are the intercepts, not the Miller indices that we are going to plug in into the equation of plane. Okay, keep that in your mind, that intercept and indices are two different quantities. Okay, they are not necessarily equal to each other. That is why that differentiation should be in your mind. Okay, so let's put these values into the equation. Okay, so let me put these values here. In place of a1 I'll put 1. Okay, in place of a we'll put the a1 intercept that we got as -1. Similarly for a2 we'll put 0, and for b we have -1 here. So but it's not necessary to put the value of b here, because this 0 our on numerator will make this whole quantity to be equal to 0. Z is 1 and c needs to be determined. This will become -1 plus 0 plus 1 over c equals 1. -1 gets to the other side of the equation, and we have 1 plus 1, which is 2. 1 over c is equals to 2, which means if we take c here and 2 here, 1 over 2 equals c. Okay, so the z intercept came out to be half. Okay, this is the z intercept, and we take the inverse of intercept. So inverse of intercept is this. Okay, now we can see here that this is not a fractional number, that is why this is the final index. Okay, L equals to 2. All right, we take the inverse of intercepts, and after taking the inverse, if there is no fraction involved, okay, then the number we obtained will be the final index corresponding to that axis. Okay, so L is equals to 2 here, and we got H to be -1, K to be -1, I to be 2, and Z L as 2. So H, K, I, L are 1 bar, 2 and 2. All right, so these are the Miller-Bravais indices for the plane that we discussed. Now you can see here in the first problem, which was quite simple. The second problem involves some other methods, and the later problem will contain more of the complex situation. Okay, so in this video I am wrapping it up by these two questions. In next video, the next part of this video will contain more problems that will contain more tricky planes. All right, so stay tuned, and because the video is very lengthy, and I think I should upload it in parts. Okay, so this is the part 1 where we have seen the general steps, and after that we saw how the HCP structure look like, and after that we have solved 2 of the problems. Now the next video will contain the more of the problems, so stay tuned, and I'll link that part 2 in the description box to check it out.